K intermediate and V intermediate. So this intermediate key value pair, once it's all thrown as an output from your mapper function, so these intermediate key value pairs would be processed by shuffle and sort. You have something called shuffle and sort. That shuffle and sort will make sure that each and every group of key value pairs sorted grouped by the key would go into every reducer. So that is what the funda is. So once we do that, your reduce function will aggregate that, so which is nothing but the logic that you write in your reduce function. So this is your word count example, as we have already seen the other day. So we tokenize that on in the mapper side, we tokenize all the words and we actually emit something called the word comma one. And on the reducer side, what we do is like we essentially get get all the intermediate key value pairs, that is all sorted and shuffled, which means that is all basically sorted based on the keys, and those group of keys, right? So those group of keys would be given to every reducer. So which means even though you have two reducers, you make sure that a group of keys does not split in the middle. So yeah, you actually give a reducer as a group of keys grouped by your unique key values. That is what the fund here is. And we saw something called the word count execution model, where we have the input is given in terms of HDFS blocks. So HDFS blocks is nothing but your default HDFS block size is 64 MB. So 64 MB of data would be actually processed, and it will be each 64 MB of data would be processed by every mapper, and the mapper will do the logic, and that logic would be nothing but the word comma one. So which means the tokenized word comma one. So that is what this mapper function will emit. And after this mapper function emits, so this output of this mapper function is what we call it as intermediate key value pair. This intermediate key value pair will essentially give you a clear picture on what is the actual next step that we need to proceed with. So this intermediate key value pair would be going through a process of shuffle and sort. The output produced by different mappers. So because your mapper functions, the mappers available are three, but your mapper functions, the tasks for the mappers would be like 100 mapper tasks. So which means the first mapper, three mapper tasks would be concurrently running, and after that has been completed, the next three might be going. So that is more of a queue. In that way, like whatever mapper function has been completed, so the output that is all kept as a from your mapper function would be going through a process of shuffling and sorting. Shuffle and sort is nothing but a process where like you sort your key value pairs based on your keys and group it all together. So the grouped key value pairs would be going to one reducer. So that is what the funda is. If you can actually that, if you don't have shuffle and sort, your reducer will not work the right way like we desire. So because shuffle and sort will make sure that even though the whole task has been distributed and like processed across several nodes, so but end of the day, shuffle and sort will make sure that everything is unified or standardized by something called the shuffling and sorting procedure, and that output of the shuffle and sort would be given to a reducer. So take an example, if you have d comma 1, brown comma 1, fox comma 1 somewhere, and another d comma 1 somewhere, and if it is not really shuffled, if I can just blindly say, okay, first half go to the first reducer, second half go to the second reducer, will we be getting the actual output? We will not be getting the actual finalized output. Rather, we can see something called 8 comma 1 here, 8 comma 1 here. Sorry, like you can see something called brown comma 1, brown comma 1, d comma 1 here, d comma 2 here. So which might not really result in the word count. So that is not a whole picture, but rather you will have to again do another level of processing where beyond reduce there is no other level of processing. So you need to make sure that at a reduce stage you need to get your desired output. So you should not really wait for another level after reduce. So that is not really possible. That is the reason why we have this beautiful concept called shuffle and sort. Let's add later part. So basically, map reduce execution details you need to understand. Single master controls your job the execution on multiple slaves. Yes, so that is something that is all carried out by a component called job tracker. Mappers preferentially placed on the same node or same rack as their input block. So this is something. So we previously saw in HDFS that data would be actually picked up based on locally available. Similarly here, so when you are actually going to give, when your job tracker is going to assign a task to a data node, which means the data node would be assigned a task which the task required task to actually process should be primarily locally available. So that is something preferentially placed on the same node. So because when you say you have block size 75 and that block number 75 is all being should be used by your task number 10. So which means the task number 10 would be given to the data node where it has preferably the block size 25. So among the three, in case the replication factor is 3. So these are all something you will have to clearly focus on, understand that visually. So mapper saves output to the local disk. Initially, every mapper, once the mapper has been finished, the output would be stored to the local disk, and then your reducer would actually collect it later after the mapper has been created. So then after that your shuffle and sort will happen, and then your reducer actual function will execute. And one thing you need to understand here is we have a mapper, we have this function, right? Let me throw you a question. So how can we optimize this? Any idea like just to optimize this? Hello, Harish, Rajesh, Rakesh.
Yeah, we are on the call
Yeah, so
actually.
any idea, can you optimize this?
Mm, Uh, from my side, I have no clue
Okay,
actually.
okay, okay. Right. So basically, if you can clearly see, is a basic model in terms of MapReduce. So you have few other optimization techniques that you can actually use. So one among that is what you call it as combiner. There is a function called combiner. See here in the output of your mapper function. So you have something called d comma one, brown comma one, fox comma one, and similarly in the second map function, so it does something called d comma one, fox comma one, d comma one. So which means you clearly see that you have two d comma ones over there. So in that sense, rather than just specifying d comma one, d comma one, and making your reducer to do the heavy lifting, so it's just a simple task of understanding, asking you to calculate 40 plus 45, how much is that? You clearly say it is 85. But asking you to calculate 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, so which means you are asked to wait and you are going to process atomic function. So which means you are going to do a very simple calculation n number of times. So that is something that you will have to avoid. So similarly, your addition process or your processing would be happening in a very smooth way in case if you have aggregated that already. So see here, if you have got d comma 1, d comma 1, fox comma 1 here, you clearly see that okay, there are two d comma 1s. So if your mapper itself can do some kind of aggregation, that is rather than giving all together to your reducer and then asking the reducer to do the aggregation and calculate the word count, but your map can also help your whole process of performance. So in that sense, you can literally say d comma 2, right? So this has two advantages. One is performance, where like performance would be improved in terms of calculation and processing, that here because the logic would be to add rather than saying 1 plus 1, you say 2 plus 1, so which is faster. So you literally get 3 rather than 1 plus 1 plus 1. So the same process would be tedious in terms of hundreds of key value pairs where you see thousands of d comma 1. So in that sense, every mapper, if it can literally say okay, what are all the number of these that it has found out, and it can aggregate that at the end of your mapper itself, that is what you call it as combiner function. So let's understand that this has another advantage, that your data size would be reduced. Your intermediate key value pair data size would be always very high. It will be very big in terms of intermediate key value pair. So when you say intermediate key value pair, the data that we are going to deal with would be very less. Sorry, it would be very high. So in that sense, we need to make sure that there might be some way to reduce your data size. So here, if you have d comma 1 and d comma 1 twice, so you have 8 characters. So rather, if you have d comma 2, we have just got 4 characters. So in that sense, you have reduced your intermediate key value pair size also. This will drastically improve your whole map reduce performance. So let's understand that. So here, that is what we call it as combiner. There is something called combiner. This is a local aggregation function for repeated keys produced by the same map. So when you actually say local aggregation function, it is nothing but you have a number of functions available. So basically your combiner function should be written, and when your combiner function is there, at the end of every mapper your combiner function will also be executed. So if you can clearly see that combiner is nothing but a same logic of aggregation, but it is happening within the mapper level itself, not on the bigger level. Here if you can see, reducer also does the same thing. Output and key sum of values, so which is nothing but the combiner also does, but the combiner does within a limit of the mapper function alone. So it actually does the aggregation only within the input your mapper is going to deal with. So that is what combiner is. It works primarily well for optimizing the whole process. So primarily decreases the intermediate data. You have a number of advantages of that. So if you can actually visualize that, be the answer. See here. So if you are using combiner, so the output of your mapper would not just be d comma 1 and d comma 1. Here it would be an aggregated value called d comma 2 and fox comma 1. So that is something that we will have to understand. So your map and combine would be actually used, and then later after that shuffle and sort will be there, and then the same process of reducer will happen. Yeah, clear with this? Yeah. Yes, Harish.
I
Go
have a
ahead.
question.
Yeah,
Yeah.
go ahead.
So in this example, right, like not the combiner, the normal presentation what you're showing right now, right?
Okay.
This is just for an example. We have three mappers and two reducers, right?
Okay.
Scenario, like who sets that these number of mappers should be there.
Okay.
I mean, from what I understand, right, the reducers will always be less than the number of mappers because finally you have to combine everything out
Yes, yes, yes.
from whatever that is, right?
Okay.
So
Okay.
who decides the number of mappers and number of reducers? Is
Okay.
this
Right.
the framework
Yes.
decides,
Okay.
or the programmer decides, or is it a configuration setting in the Hadoop?
Yes,
Which of
exactly.
these
So
three?
it's that's a very good question. So basically, this number of mappers are decided based on the configuration settings and the configuration of your Hadoop cluster. So that is what the whole answer is. So when you say that, so that is the reason why most of your Hadoop development and integration would be something more of a gelled process. So where whatever component, it is not just a program that says I can just write the code and I can give you no, because he needs to optimize it to the cluster size also. So that is one thing. And if you give a map reduce job, your map reduce job based on the job and based on the Hadoop cluster size, you literally have something called the number of mappers that would be defined by your configuration itself. So when you say like these are all some simple metrics that you can actually take up. So the total number of mapper functions would be different, but the actual number of mappers or the actual mappers that will actually run for you. So if, in that sense, so this would clearly mean nothing but your data node. So when you say mappers, right? So mappers are nothing but the functionality that will be taken by your task trackers at that point of time doing your mapping function. So that is what mappers are. In that sense, when you say number of mappers and number of reducers to be defined, you clearly have something called configuration file where you already define something called the default mappers and default number of reducers. So we will be seeing that later, but essentially that is what the answer is. So it is you can still write it from your program also, or you can still configure it if it is not really configured in your program, in your Java program. So rather it would be picking up from the default values that we call it as Hadoop conf file. So we will be dealing with that in the later sessions.
Thank you.
Otherwise, it does not have anything to do with your programming. So you just give it to the framework, and framework takes care of it.
Okay. Thank
So let's get started with something called So later, after understanding this basic MapReduce functionality, you'll have to understand input formats. So we previously had seen something called your this one, right? So you we actually see something called your this is something we have seen, right? Your map reduce programming model in terms of key value records, you have something called map function where you have input key value pair and you actually emit as intermediate list of key value pairs, and then that intermediate list of key value pairs would be produce it would be used by a reducer function, and then the reduce will emit the output. So in that sense, when you say map function, what does map function mean? Here map function means to us something called it need read some input key value pair. So how does that input key value pair get recognized? That should be one important question you should actually ask us. So basically, when you say input key value pair, so basically take an example. You are going to give one text file. So how do you say that a text file can be represented as a key value pair? So there are several uh, input formats what your Hadoop supports. So we'll be understanding that. So we'll be just picking up the important three input formats that is more standard here. So the most important input format is what you call it as a text input format. So which would be the default input format if you have not explicitly specified anything. So when you say that text input format, so each record is a line of input. So when you say each record is a line of input, yes, it means that every line would be considered as a record, which means that record would be used as a value for the key value pair. So let's understand that how it is getting represented. And basically the contents of the line would be actually terminated by using some value called a carriage return or a slashing, so which is nothing but a new line character. So that is what we call it as a text object. So see here, if this was an input file, so you give something called an input file, and that input file would be processed by your text input like your Hadoop, and by your initial Hadoop pre-processing task of getting into HDFS. So what it will do is, so this input file would be processed by your text input format, and what it would be represented as some random value from this value. So on top of the tree would be on the value side, and the key would be a random value. So to be very clear, the key would be an offset of the read data at some point. So which means at this point the first line is read from the line offsets. They call it as line offset, or to be very clear, it is mostly like the word offset. So which means you have something called letter offset. So you have something called 0, and after on you have something called 3. At the end of this you call something called 33. So that is what you call it as line offset. So end of the day you can just understand that the key that we have, that is all generated by your Hadoop framework itself, would be used just for processing, because like essentially you have some standard rule called the standard rule will always accept only key and value pair. So that key should be some value. So here the key is not something that we have generated, it is clearly something a randomly generated one. So we use that you we use make we make the best use of the value, because we are going to ignore the key, because while processing in your mapper function you can clearly pick only the value and then process later. After that mapper function, it is under your in your hands to actually emit what the intermediate key value pair should be. So you have total control of it. So because since Hadoop framework accepts only in terms of key value pairs, you will have to understand this. So this is your default text input format. So, and there is another key value text input format. This is another input format where essentially if you have in the input file itself, if you have something called, okay, in a column we have something called, okay, there is a user ID, and there is another column where you have something called value. So which means, like, take an example, in the input file itself you have something called key and value, where you can clearly define what might be the key, rather than asking the Hadoop framework to actually generate some key, rather than asking the Hadoop framework to generate some key that might be random thing. But if you believe that in the input itself you will clearly have some key that you can make use of, then you can go ahead with key value text input format. So where you need to just say the delimiter of that. So by default the delimiter character would be tab, but you can still override that by use specifying the separator via mapreduce.input.keyvalue line record reader dot key dot value dot separator property, where you can specify what is the character that is used to separate these. So to interpret such files, so key value text input format is appropriate. So that is something that we'll have to understand. So when you say this is a file, you have something called, you have an input file and you have something called tab characters. So this tab characters is represented here as a arrow here. So this is what the input file is. When you read with this input file, sorry, there is a mistake here. So before line 2 you should actually do an enter, so the line 2 should come here. So this would be more relevant in terms of handling data. Take an example, log analysis. If you are actually going to deal with logs of data where you want to actually understand the user's behavior, so every log will have something called a uniquely identified column that might have something called a user ID, or that might have something called an IP address. So IP address or user ID can be used as a unique key, right? So in that sense, that column can be identified and that column can be used for making that column value as a key thing, and comma and something else as a value thing. So that is what this whole funda is. So you have something called key comma value. So that is what key value text input format is. Once you actually do this using key value text input format, you have something called line 1 comma something, line 2 comma something, line 3 comma something. So which means the key itself is something that you have defined. So that is what key value text input format. So these are all some few standard text input formats. Finally, let's understand that so not always you will be dealing with text data. You might also deal with some like a complex structure data where you have something called XML. So in XML, you can't really consider everything as a line by line input, right? So because XML data means you have something called records. So the records are all not something that is all confined within one single line, as we have seen previously. Rather here, XML would be confined, like every record might be actually going beyond 10 lines or something else. So in that sense, what would be your answer? So how do you process this kind of XML data? XML data can be considered or processed in terms of two types. So one is your basic level of one is nothing but your XML parsers, and the other one is using your regular expression. So which one do you think would be more efficient? XML parsers, do you think it would be more efficient? Okay, so basically XML parsers might seem to be efficient in terms of usability, but in performance, XML parsers will not be so efficient because you are going to, but that is one good idea for going with Hadoop, because when you say XML parsers, if you are going with XML parsers, you can be away from the headache of how this record is being split in the middle. Because when you say HDFS blocks, right? So HDFS block splits the data in the middle of 64 MB, right? If you are going to give some 1 GB of file, 64 MB of file would be actually split across several things. In that sense, what happens over there? So you might not really know where your for an XML parser would help you in terms of understanding the data, in terms of analyzing the data, in terms of reducing your overhead on writing your regular expressions, on processing the data. So which means when you see like your work has been reduced, so which means there might be a little overhead. Using parsers would actually not be an efficient way in terms of processing. But if you want to have very high end processing where you want to actually improve the whole performance, then you might consider using regular expressions to manually consider XML data as text files, and then process that, and then get that derived, and then derive some output out of it. So that is what the funda is, right? So basically, even though XML is a document, XML has a structured document, you can consider still XML as a text file and still use something called regular expressions to parse through that. Because in case of XML parsers, it will generate a DOM, which means an XML DOM, and through DOM it will be parsing through that. So which means it is more processing and a little more overhead you have, but at the advantage of not really getting into this much level of depth of actually processing your XML as a text file. Got it? Yeah, go ahead, Harish.
Yeah, I have one question actually in the diagram what you were showing before, right? Like, let us
Yeah.
say we were talking about random number being generated by the Hadoop itself,
Yeah.
right?
Right.
You showed
Yes.
you talked about line offset, word count, word offset, and this random number doesn't need to be a sequential number, right? Like
No,
from
does
zero
not
to
mean. Yeah,
100,
this random number clearly is
right,
not your line number. Clearly.
right, right. That's what the slide says, right? So can the same random number be generated on a different mapper on a different node? That means
No.
right now this input is 30, 0, 33, 57, 89 on one node. That
Okay.
means this is the output of one mapper which is running on one compute node. Can the
No, this is
same
not the
number be
output of a
generated
mapper. No, no,
also?
no. No. If you got this clearly, this is an input of a mapper. Output of a
Okay.
mapper is in our hands, right? It is our
Right, right.
logic, right? This is the input
Exactly.
we are going to give to the mapper.
Okay. So it is just reading off with a
Yeah,
particular
exactly,
thing.
exactly,
So
exactly.
so
But
so let
essentially,
so let us
in
say
terms of key value pairs.
right in terms of key value. Let us say the same text format on the top of crumpet tree, the same
Okay.
file because there's a replication factor, right? The same file is going to reside on a separate node, right?
Yes.
If
Yes.
if it is acting on the same file, it will be the
No, it will
same
not act
offset.
because your name node takes care of it. This will happen in the HDFS side itself. Once you load into your HDFS, and if you are
Okay.
going to start something, so each input would be read in terms of key value pairs based on your text input format. What is the input format that we are going to specify? Because this is now something that we don't really need to worry about, so I can actually clearly understand what your question is. So you say like, okay, we are actually generating, like you have thrice, right? So you say, okay, you have the same data thrice, which means your replication is happening thrice, and how come we can actually say that this would be a unique thing, correct?
Exactly. Because
Right.
because if
So
you hit the same block
yes, yes,
on the
yes.
same three
Let me explain.
nodes,
Yeah,
okay.
let me explain. So in that sense, when you say any block that you say, right, so that block would be available thrice, but that does not mean like thrice you will be actually processing all the data. No, the answer would be no, because when you say any block size, the any block size you take up, this would be your input key value pair. So in that sense, what essentially happens is you when you actually consider any block size, so this block would have another two replicas, so that is another two places where your the same data is available. So that does not mean like this data would be actually again generated twice. No, basically your name node says always stick with one. So in case of any failure only, you will be actually going to search for the second one. So that is what the funda is. Not essentially all the three would be focused at any point of time. Only one would be focused. So in case of any
Okay.
failure of that data, that block size, so then something else would be focused on. So these are all some kind of backup mechanism. That's it. So it is not
Okay.
something that you
This is
all
more
have
like
and you
a
will be processing that.
something
So
like
that
a
is what the
disaster
framework will.
recovery and okay.
Exactly, exactly. So we'll have to manage high availability and everything else, right? So when you
Right.
say like this can scale up to hundreds of clusters and even two clusters failure, we should be in a position to handle that and tolerate that. Fault tolerance
Exactly.
should be a part of it. So that way this
Exactly.
will be helpful. Otherwise,
Okay.
like these are all something code framework itself takes care of.
Okay. I have a related question actually, Sarona.
Yeah,
The
yeah.
thing is, okay, now initially you had 1 GB text file, right? Which is
Okay,
sitting,
okay.
uh, imagine it is not even in HDFS file format. We got a zip file from FTP location. We now
Right.
unzip the file or tar the file, and then, we did a import
Yeah.
FS inside into Hadoop, right?
Okay.
So, so automatically
Okay.
this file system now got split into 64 MB chunks by the framework, and it is being stored based on its own random
Yeah.
algorithm to whatever node it wants. Okay. My question is, does the
Exactly.
name
Exactly.
node
Yes.
have a indexing of what file is going to what node, or if you split the 1 gig file into, let us say, the way you calculate 64 mod, right? Let us say it is split into 100 different parts.
Yeah.
Part A has first 10 lines,
Yes. Yes. Yes.
next 20 lines, 30 lines, right? So will the name
Correct.
node,
Correct.
does
Yeah.
it have
Yeah.
like indexing table telling okay, the first 10 lines are on this node.
In fact,
The
yes, because
replication,
the name node's primary
okay.
job is to have the index.
So it's like a
Yes,
metadata repository keeping track of where
uh,
what
to,
is residing.
to be mentioned that very clearly, right? Let me actually take you through that session. So that was something that we focused on, right? Because name node's purpose itself is to manage a metadata. That is what the whole funda behind name node is. See here, we mentioned something called name
Okay.
node is a metadata.
Okay.
Nothing else is a work of name node. Name node's primary focus is to maintain an index, which data is available which place. So what are all the replicas of that? So where in terms
Okay.
of when someone is going to ask you, name node would be question. So then name node says, okay, you, whatever data that you are requesting is available at that place, so you go and check it. Make sense? You
Sure.
understood it?
Sure. Sure.
Yes,
Sure.
you're right.
It makes sense.
Yeah.
Yeah, I understood, sir. I mean, like the reason why I start asking questions is I
In
can
fact,
never
we
connect
appreciate
that.
that.
I can
Okay.
never connect things until unless I come there
Yeah,
because
yeah.
of lack of understanding of concept, right?
In fact,
So
you
once
need
I
to
go
be
there, I try to correlate back what we went. So that's why
right, right.
I asked the
I
questions.
really
That's
appreciate
all.
that. So we encourage you asking questions. So because the whole funda behind this is like getting yourself comfortable with that. So it's not just we see, you need to realize that. Yes. Fine, then we'll actually catch up on the next class. I'll be giving you an update reminder on that. So the next session will be on more of a, we'll get started with the practical hands-on sessions also. You'll be shortly getting your cloud server access. So I'll just check with the front office what is the status and I'll just give you an update. Okay.
Yeah.
Yeah. See you, Rajesh. See you, Harish. And
Yeah.
Jay,
Thank
see you.
you. Yeah. Yeah. Yes. Thanks.